the last class? So, who are the present in the last class? Please wait, one by one, not like that. Okay. Yeah, but and who else? One. You can please raise your hands boldly because you came 2 classes continuously. Ramesh. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 members are there. So one by one, what is the last class? First class. Who are there in the first class? So can you please stand? So what is the first class we discussed? What are the objectives? Okay. What are the objectives? Can you please name what is the objective of first unit?
Basics of thermodynamics.
Basics of thermodynamics we will learn in the first class. Okay. What are the basics means? Basic properties or basic things. Okay. What is the thermodynamics? What are the properties of thermodynamics? So these are the fundamental things we learn in the first thermodynamics. That is the first class. We discussed more or less that's the only. Yes. Who is the first? Who were there in the first class? Yeah. Yeah. Now in the last class, can you please discuss in the last class?
We have discussed about laws of thermodynamics.
Laws of thermodynamics. Yeah. What is the first law of thermodynamics?
Energy can be created.
So what do you call another name also with this? Conservation of energy. Yes. Yeah. She will explain. Yeah. What is the conservation of energy?
Energy can neither be created nor be destroyed, but it can change from one form to another
form. Actually, isolated system. Any isolated system, total energy is constant. Okay. So total energy is constant, but and the energy cannot be created and destroyed, but it can change one form to another form. That is the first law of thermodynamics, and also it is also known as conservation of energy. Law of conservation of energy. Very good. So who else? Ramesh. What is the purpose of thermodynamics to the pharmaceutical engineering second year semester? What is the purpose? Why are you learning this subject? What is the use of this subject?
To know about
you can you please explain to your friends who are absent in the last class, previous class also.
మనం లార్జ్ అమౌంట్ ఆఫ్ డ్రగ్స్ ని ప్రొడ్యూస్ చేసే క్యాపబిలిటీ మన బ్రాంచ్ ఉంది. సో మనం విత్ తక్కువ ధరకే ఎక్కువ డ్రగ్స్ ని ప్రొడ్యూస్ చేయొచ్చు.
How it is helpful to produce the pharmaceutics in a large amount with a low cost? How it is helpful?
By using different equipments, and then especially by using thermodynamics like
yes, please listen. Correct only you are saying, what you are saying correct only, but little elaborate, that's the only. How? See, because you are learning subject, what is without use and without a purpose, you are learning means you are kicking something in the dark. So you don't know without purpose means if you are doing anything without purpose means you don't know why you are doing. Then what does it mean that particular day you learn for particular reason means you want to learn, okay, I have to go. But one particular day someone will ask why you are learning. If you don't know that, you will be blanked and also you will say no use of this subject. So it should not be that the case. Every subject is useful. I explained pharmaceutical engineering, especially chemical engineering related because I came from the chemical engineering background. So chemical engineering related subjects are how they are related to pharmaceutical engineering. How one subject will help you in a pharmaceutical industry. Every subject like a thermodynamics, fluid mechanics, mechanical unit operation, heat transfer, every subject. Like I also explained the thermodynamics. How it is helpful? Why are you learning this subject? What is the use of that? So you should not waste your valuable time without purpose. Why are you learning? Also I should not also waste my time also. There is a purpose. There is a great potential to learn every subject. Of course, first goal is what is your pharmaceutical engineering as a pharmaceutical engineer? What is your first goal? First goal?
Produce the large amount of drug with less money or less amount of cost.
So by how? By designing the total planned process. For example, paracetamol drug you are producing. One company is producing. Okay. So paracetamol drug. How can I reduce the cost of the the drug by applying a new methodology, new process. So means you are a designer to design a one particular pharmaceutical process. Not only the process, what else? Equipments. So in the process, you need so many equipments are you needed to design them. So design is what? What should be the diameter? What should be the thickness of the vessel? And what should be the height? What should be the width? So that cannot be designed. You can design any layman. So because we need lot of subject, because it depends on the cost. So whatever the for example, this same task I have given to somebody like a blacksmith, he will also prepare, but he will prepare it according to his own assumptions. Maybe that may not be useful. So for example, you go to the market, you will purchase one vessel because already by his own pre-assumptions he prepared that. You will take that one, you will want to use that vessel for your own purpose. Sometimes exactly it is suitable, it may not exactly suitable to your purpose. For example, you want to prepare the food or some biryani, something like that. Okay? So in the same way, but in the industry it is not like that. Na? You will purchase them because already somebody is prepared like that. We will purchase from them, and after that we want to try to utilize that vessel for our own purpose. It cannot be like that. Na? So means first we have to design. As in the pharmaceutical engineering background, they has to be designed. After designing, that has to match to the process, then only it can be used, because anything is based on the profit oriented, so profit has to come. Okay, so means your objective is first you are going to design the pharmaceutical engineering process. Okay, not only the process, equipments also. What are the equipments are needed to produce a one drug? So in this subject, how it is helpful to this designing the process or designing the equipment? How it is helpful? So what is my question is that? How? Now your friends will listen.
It will be helpful for the how much amount of heat is required for the process.
Particular work, task. Very good. For example, we want to do mixing with the agitator. How much I need, for example, to do that particular task, how much heat energy requires? So heat energy converted into the electrical energy, electrical energy will be converted into the mechanical energy, mechanical energy do that work stirring process. So to do that stirring process, how much heat energy requires? Okay, that is the mixing purpose. Otherwise, if you want to separate something, two compounds, how much energy is required to separate them? You cannot apply random energy. So that otherwise what will happen? Energy will be lost. So much energy you are producing, energy will be lost, is not correct. The industry want to utilize maximum percentage of energy without loss. Okay, so means it cannot be done without any calculations, without design. Okay, yeah, please, thank you. So means as a farmer, this subject will help you how to determine the heat energy to do one particular task. For example, I ask you, Sai Tejana, Sai, can you please stand up? He needs some certain energy to stand up. How much it requires, he doesn't know. But so that's the task. Task is to please stand up. So how much energy requires to stand up to 5 minutes? So same thing in industry, to do any particular task, any task you take, we need some amount of energy. So this pharmaceutical engineering means this thermodynamics will help you to determine or calculate that energy. Okay? Yes, please. So that is the first objective. What is the second objective? Who are there in the second class? Second class? Somebody? Are you there in the second class? Were you? Yes. Can you please stand? What is the second objective of this course?
It deals with the direction of the process.
Yes. So for example, you are doing something, you are preparing the tea. I already said this example. So while mixing some ingredients, will it be formed a tea or coffee? So what is the direction? Based on what direction it is going to form a tea, or what direction it is going to form a coffee?
Selecting of the raw materials.
Selecting of the raw material, even though sometimes you set the same raw material, you say whatever your desired product may not form. It depends on the direction. It depends on the thermodynamic properties. Okay, that is called entropy. Okay, so means it also helps you to understand, I am doing this, will it go in this direction only, this product only will form or not. Yes, after confirming the thermodynamic property at this way it's going to only form, then you can start the work and you will get that product only. Otherwise, if you are doing something, you want to prepare a tea, but if the coffee prepared, then what's the use? So that is not like that. Okay, so means this second objective is this subject is also helps you to understand what is the direction is going. Direction also helps. Okay, that is the second objective. What is the third objective? Please say next one. Rosie was there. Pardon? You see and tell, no problem. Just read otherwise.
Difference between the properties of the systems.
What do you call that? Correlations. So it also helps to develop the correlations. Relations between some properties. How the temperature, when I am increasing the temperature, how the density is changing. Our concentration is changing. Our viscosity is changing. What is the correlation between temperature and density? Our temperature and viscosity, our pressure and density, pressure and viscosity, our other properties. These correlation laws will be developed using the thermodynamics. Okay? So that you don't need to do experiment with something. For example, at room temperature you are there, the system is there at room temperature means water is there in the bowl. So at room temperature it is there. If you want to know that at 25 degree temperature the density is 1. But at 75 degree temperature, what is the density? You don't need to do experiment. This correlation is already there. That will help you to understand that. So you can easily determine the viscosity or density. Means this subject will help you to develop you will going to develop the correlations. Okay. First fundamental correlation you will understand first. After that, by your own how to develop the correlation, that also this subject also will help you. Okay. That's the fourth object. Third object. Fourth one. One by one, not like that. Who else came? You came in second class? Yes. Navina? What is your name? Niti. So are you there in class? Can you please tell what is the fourth objective?
Determine the phase equilibrium.
Phase equilibrium. Because this is industry related, phase equilibrium and chemical reaction equilibrium also. When for example I am changing the phase, one state to another state, solid state to liquid state I am changing. If I am changing like that, when these two states are going to be in a equilibrium, means no further changes. Okay. Otherwise chemical reaction, A plus B gives rise to C plus D. So this is the chemical reaction. When this chemical reaction is going to be in equilibrium means there is no further changes. There is no formation of production. So that equilibrium, where this equilibrium going to form particular this reaction, then we can know, okay, these are the properties at this temperature, at this pressure, this reaction is going to form an equilibrium. Okay, then I know where they are going to form an equilibrium, then I can avoid that, to do not reach that temperature and pressure. So what can I do? So increase the temperature or increase the pressure, something you do to avoid that. So then I don't reach that equilibrium, I don't stop my reaction at there, but because of the increase in the temperature and pressure, and I will overcome that equilibrium and go to the production. So that means it also helps to determine the equilibrium, phase equilibrium and chemical reaction equilibrium, so that I can know that. When I know that, I can try to avoid that if I want. If I don't want to avoid, I can use that one. Okay. So these are the four objectives. Okay. So now next one is the first unit content in the first topic is the types of energy. Okay. Please write types of energy. Types of energy. Well, this is the first unit, first content, first topic. So first one, types of energy. Please write types of energy. So you already explained so many types of energy. You are in the last class, everyone explained. But these all energies are broadly classified into two categories: kinetic energy and potential energy. Now please write that one. There are several types of energy. What do you want? I cannot understand by standing like that. You have to ask something. What do you want? You speak loudly and tell to me. You want to come into the class. Just ask that. You are standing outside. How can I understand? I cannot read your mind now. Very good. That intention is very good. But you just ask it, then you can know it. What is there in my mind also. Yeah, please come back and stand up. Because it came late. Stand here. Both of you. Okay. So types of energy. There are several types of energy. They are mainly categorized into two. Kinetic energy and potential energy. Okay. So have written everyone?
Yes, sir.
So next, so these are the few energies we are discussing here. So there are categories into kinetic energy and potential energy. In that, please write kinetic energy, mechanical energy. You already told mechanical energy, thermal energy, solar energy, and geothermal energy also considered as the thermal energy. Okay. Next to electrical energy, in the hydroelectric energy, wind energy, nuclear energy, tidal energy, and steam energy also considered as the electrical energy. Next, sound energy, radiant energy, or electromagnetic energy. So next one, potential energies. Gravitational potential energy, elastic potential energy, chemical potential energy. Gravitational potential energy, elastic potential energy, and chemical potential energy. Apart from them, any energies is increased in anyone cell. So you know that, but it is not enlisted yet.
It is there.
One by one, can you please raise your hand? Otherwise, shall I ask? I will ask you. What is his name? Vamshi. Vamshi, do you know any other energy that is not enlisted yet? If you don't know, simply say don't know. That's it, no problem. Any energy you know, but it is not here. Everything is here.
Yes,
Tidal is there. Internal energy. What is that? Internal energy now. Okay, internal energy. Yeah, you can consider. That is very good. Internal energy. Electrostatic energy, very good. Yes. Chemical energy is there now. Chemical energy is there. Colloidal energy. Colloidal energy. Of course, because of the time. Yes. Yes. Colloidal energy. What else? Photoelectric energy. That's a solar energy. That is effect actually. Photoelectric effect. That is not energy. Effect. Photon energy is there. Electromagnetic energy. Electromagnetic. Na? What else? Vamshi, please say. Anyone? Solar energy is there. Pressure energy. Excellent. It's not there. Pressure energy. Very good. Magnetic energy is the electromagnetic energy. Both are same only. What else? Who will tell? Good name? I forgot. Snigdha, na? Yes, Snigdha. So any energy, do you know? Enlisted. Can you please guess? Hydraulic energy. What is the hydraulic energy? Please say it. She will tell. Because she told now. What is the hydraulic energy? Really, I don't know. Maybe I am confusing. Pressure energy. So it is same as pressure energy. Yes. What else? Anything? Okay, please say. Now, what is the mechanical energy? Bharat, please. If you know, see, I am not asking. You have to know it. If you know it, you please tell. This is discussion point. This is the only discussion point. If you know it, work done by the system is the mechanical energy. So why do you call them mechanical?
force is required.
For everything to move, force is required. Fan, yes. What is that energy, fan? Huh? How the fan is rotating? Please wait. How the fan is rotating? Anti-clockwise is rotating. Clockwise is rotating. It's okay. Okay, clockwise rotating. How it is rotating? I mean, what energy it is utilizing and electrical energy. Electrical energy converted into mechanical energy and produced a wind energy. Okay. So now, what is the mechanical energy? Yes, she told something. Energy requires to move certain object. Is it that mechanical energy definition? No. Who said no? Can you please? I will ask another one. What is the mechanical energy? Please guess only. I am not asking you. We have to know it. Just guess. Simply guessing, so that we have some discussion. Mechanical energy.
With the help of any other energy, we can create movement in the system.
Okay, movement in the system. Machine is the, of course, considered categorized into mechanical, because the movement is there. That is called energy. Because the movement is created, that is called mechanical energy. Movement is created means mechanical energy. The energy is generated or created by the moving parts of the system. Because something is moving, so here moving means mechanical movement. I have to mention. The energy is created because of the mechanical movement of the system. So that is called mechanical energy. Now please write mechanical energy. Please sit. Brother, please sit. The energy possessed by an object due to its mechanical motion. Its is not there, please write. Include also. Energy possessed by an object. Energy possessed by an object due to its mechanical motion. Due to its mechanical motion. Examples are a swinging pendulum and a hammer. Now I will ask you, can you please tell other example apart from two? One more example, so that you will write.
Any rotating pump, sir.
Any rotating pump. Okay, means pump. Okay. Please write pump also. Pump, please say. Yes, she will tell. One more example. Mechanical energy. Example. Practical example. Any. You can take your pencil. Huh? Sheaving machine.
Sieve shaker. Sieve sir. Sieve shaker.
Because of the movement, is there? Yes. What is sieving machine? What is it? Sieve shaker.
Yes, sir.
Please write. Practical example. Now next, Vikesh will tell. Vikesh. What is another example? Pump, she told. Rotating fan, mechanical energy. Yes, right, fan. Rotating fan. Who else? Next one, she will tell. Another example.
Sewing machine. Sewing machine.
She told, na? That's the only.
Sieve.
Okay, sewing machine. Okay, very good, nice. Because there is a movement. Yeah. So moving car. Simple example. Who else? Moving racket. Walking, running, jogging person. He has a mechanical energy. Eating and moving hand. Moving hand, mechanical energy. Okay. What else? Yes. Whatever you are having now, you are sitting. Yes, ball means you studied already in MUO, mechanical unit operation. Very good. Ball mean and jaw pressure. Very good. So you are sitting now. What is the energy you are having now? Potential energy. Yes, potential energy you have. So much potential energy you have. Okay, please utilize this. Okay, convert this into the mechanical energy, education energy. Okay. Next one, thermal energy. Thermal energy. Energy associated with the movement of atoms or molecules in a substance. Energy associated with the movement of atoms or molecules in the substance. Okay, so commonly referred to as the heat energy. Okay, so thermal. So what means the thermal energy means actually it is also considered as the internal energy also, because in a substance you take any substance. For example, you take this one. This is prepared by what? By which material? What is this material? What is this? She is saying wood. Wood only? Yeah, please wait. Yes, we have a debate. Very good. She is saying wood. Is it a wood? Yes. You are saying wood. Can you please raise your hands? Raise your hand. Wood. Can you please suggest her? Can you please support her? Wood. Yes, last one. What is your name? What is this prepared by? This bench? Plywood. Plywood. Is it a plywood? This is not plywood. I am saying I don't know. Yeah. Some alloy. Some metal. Okay. So metal in the metal molecules are there. Metal molecules are there. So always the molecules, what, for example, you take this metal, this bench is prepared, the metal is like a iron. Okay, so this bench is prepared by the iron. In that molecules are there, that is Fe. So now always these molecules are vibrating itself only. Because not because of we are supplied any heat, but not because of we did something. Okay, but without doing anything, they vibrate themselves. Okay, but that energy, for example, external energy is applied, that energy is absorbed by this molecule, the vibrations will increase. Naturally, they have vibrations. These vibrations will increase. After the certain time, the vibrations are increased. That energy converted into the heat energy. Okay, means again that energy, whatever the energy is absorbed, that will be released. But maybe not exactly 100% form of heat, or some losses also, like in some other forms, like some, for example, viscosity will change, the density will changing, some other property changing. So means some energy will be lost also. Naturally heat energy means, if we don't call in a natural case the heat energy, that is called internal energy. When we apply the energy, the molecules vibrations which are increased, they are not started, they increase the molecular energy from the initial state. So then that energy, after some time, that energy converted into as again heat energy. Okay, so that is the means, we don't have exact definition, we are just explaining what is the thermal energy. In the thermal energy, molecules are atoms, vibrations are, motions are there. So that is the thermal energy. Okay. So next one, what is the thermal energy examples? Burning of coal. That is the heat is releasing. What else? Solar panel. So solar panel is not heat energy. No, that is different energy. Means you can say that solar solar power or sun, solar energy that you can call. What else? Yes, excellent. Yeah, it will generate the lot of heat energy. Eruption of volcano.
Sir, what is the difference between solar energy and Sir,
Same only. This is the category into the thermal energy only. So here solar energy, please write another. These are also considered as solar thermal energy, solar energy. Next, geothermal energy. Yes, yes, that is true. Means electrical energy is converted into heat energy. Straightener, excellent. That is also. The electrical energy is converted into heat energy. Rice cooker lamination, yes. Oven, yes. Microwaves are converted into the heat energy. The rice cooker.
electrical. Yes, sir.
Of course, you can say natural gas, when it is burned, the heat is released. So, rice cooker case, there is application. Okay.
How is rice cooker?
Cannot be, yes. Water heater, yes. That is the application only. But you can say that gas stove is a thermal energy. But a electrical pressure cooker, it cannot be because it applies the energy. Of course, it also emits the energy after some time. You can maybe vague application we can say. Next, solar energy. Please write. Solar energy is the radiant light and heat from the sun. Okay. Next one is geothermal energy. Geothermal energy is a form of renewable energy derived from the heat stored beneath the earth's surface. Okay. So these are the thermal energy categories. Apart from them, any thermal energies are there. We said thermal energy like a heat energy, and solar energy, geothermal energy. So any other things are also come into the thermal energy. Any other? Nuclear energy. It will be released. Yes, nuclear energy. But applications are different. Yes, nuclear energy, steam energy. What else? Next one is the electrical energy. So these are different types of energies. Electrical energy. Electrical energy. Energy associated with the flow of electric charge. The energy is associated with the flow of electric charge, such as energy powering electric device or electric systems. Example that is. Yeah. So now some example. Example means what are the other energies will convert into the electrical energy. Vikesh will tell. Because you are yanning. What are the other energies? What are the other energies that can be converted into electrical energy? Mechanical energy converted into electrical energy. Directly. The source, because of course you can do many ways. See, mechanical energy also part of the, it can convert the electrical energy, but it is not that is not the source. What is the source first? Turbines. Turbines, what do you call? From what is the source? Mechanical energy, no. Hydro, yes. Hydro power, hydroelectric energy. Yes, one is very good. Next one. Next, another one, electrical energy. Please say. Hydro means you know, na? Using the water, the electricity is generated. How the using the water electricity is generated? You will tell. She will tell. Can you please explain how the hydrothermal, or what do you call hydroelectric energy? So how the hydro power is converted into electric energy?
The hydroelectrons are set up with the tidal of the water.
Hydro?
By the movement of the water, they rotate hydro. Turbine.
Which one? Turbine will rotate. Yeah, then
And they convert into electrical.
how when the turbine is rotating, the electric is generated? Because I am also rotating. Will it create electrical energy? Will it create? Huh? How? Then how it is generated? Huh?
Not through tidal, but directly
She said hydro. We will
Yes.
stick to first hydro, next we will go to tidal.
no, she said turbine, so that is not required.
No, it is required.
To convert into electric energy.
Yes.
Movement of water from certain height.
Movement of
certain height.
Movement of certain height, that's the reason the turbine is rotating. That's true. But I am asking, because of the turbine is rotating, how the electricity is generating?
Mechanical energy.
Sai Teji is stand.
Sir, when water passes through the turbine, they rotate now, sir. When they rotate, there are two magnets.
Very
when
good.
the axle rotates, the magnetic flux creates an electricity.
Excellent, excellent. There are magnetic charges. When the because of the hydro means potential energy converted into the kinetic energy, the water is coming and rotating the turbine. Okay, when the turbine is rotating, around the turbine there is a magnetic coil. When it means this and this mechanical, what is the turbine is there, it is coiled with the electricity. There is a electricity generated. Electricity is passed. So because of the it is rotating, the magnetic flux will continuously changing. Because of the magnetic flux is continuously changing, the sometimes electricity is pushing, means electrons are pushed by the magnetic field by one direction when the magnetic field is rotating one direction. If rotating another direction, the field is pushing which are electrons in another direction. So that we can see here. For example, so water is coming and turbine, this is the turbine, the mechanical device is rotating. So around this magnetic coil is there. Okay, this magnetic coil, because of the rotation, this is also coiled with the electric wire. This is the electric wire, this is the magnetic field. So because of the magnetic field doesn't want to change. Because of the rotation, magnetic field is changing. While the magnetic field is changing, it doesn't want to change. That's the reason that is converted into the electrical flux. So that electricity is, this magnetic field is pushing to electrons to move. So we need movement of the electrons only, na? So that is generated like that. Okay? Somewhat understood? So this is the intermediate thing. Okay? Yeah. Next energy is hydrothermal energy. Please write examples. Not examples. These are also comes to electric energy. Hydroelectric energy, wind energy, nuclear energy, steam energy, and tidal power. Tidal energy. So, tidal energy. These are all some. We need to somehow make some movement. If I create some movement, that can be easily converted into electric energy, because I need to just place some magnetic coil, and that will coil. So because of that, because of the movement is created by the wind, movement is created by the nuclear energy, movement is created by the steam energy or tidal energy or hydro power energy, whatever. So when it is created, because the movement is created, because of the magnetic coil is there, the electricity means the flow of electrons are changed. That's the reason two types of electricity are there. One is the what do you call? AC, DC. AC means alternating current and direct current. So generally this type of power is created only alternative only, AC, because electrons are pushing one direction when the coil is when this mechanical turbine is rotating again, because the flux is changing and pushing another direction. So pushing the electrons only one direction, another direction. Okay, that's the reason we are getting the movement of electrons to the transformers are going, from their transformers coming to our home. Okay, just movement of electrons. There no loss, nothing. Just move. Energy is changing. Again, movement of electrons only. Okay. So this is the electrical energy. Next, sound energy. Please write sound energy. Sound energy. Sound energy produced by vibration of particles. Vibration of particles in a medium, such as sound wave generated by the speaker or musical instrument. See, you are always in the class, no one is there, you will speak now. So lot of energy is generating, that is the sound waves. So that sound wave is absorbed by this wall, surrounded by the walls. So that is storing the as a potential energy or kinetic energy in that. After that, after something, what will happen? That will be lost because in the form of heat energy. Whatever the energy is absorbed by the sound, whatever the sound you are making, that sound is absorbed by the benches, walls, everything is surrounded by you. That energy is absorbed. After some time, as the heat loss, it will be lost only. But you can think that how can you utilize this energy? Because we continue to speak in the classroom. So something you prepare some device that cannot be converted into heat energy, but I can use that energy in the other form of energy, so that I can use that. So that like that. Okay, means you can in the classroom most of the times you will speak now. So lot of energy is generated. So how can you utilize this energy? Because actually it is most of the energy in the universe is we are not utilizing. Loss means we are not utilizing particular purpose. That is a loss. Nothing is a loss. We are not utilizing for our human beings purpose. We are calling it as a loss. Okay? So means how can I use this energy for our particular purpose? Any purpose you say. Rotating the fan is a purpose. Something standing is a purpose, sitting is a purpose, everything is a purpose only. So how can I make sure that this energy can be utilized? So you can think that as engineers, please think that direction. Lot of energy is not utilizing particular purpose. How can I make sure that this energy be utilized particular purpose? You can think like that. Okay, that is sound energy. Next one, last one. With this, yes, that's the reason. Last one, radiant energy. Radiant energy or electromagnetic energy. I said to the only class here has to inform. Only, if the time is really up, but just mention, not all, please. So radiant energy or electromagnetic energy. So I will take the attendance from Joshi Madam. So I will take the attendance again. Please write this down. So energy is carried by the electromagnetic waves, including visible light, ultraviolet light, and other form of radiation. UV light, infrared light, everything comes to electromagnetic energy only. Okay, means that from the light the energy is coming. So that is also energy only. So means energy means this you can use particular purpose, that we call energy. Energy means you can utilize this for particular purpose. You can do something with that. So that is, the energy can do that. Okay, energy is also equal to the work only. Work means it can do some work. So some displacement, something that can be done. Okay. So with this I will stop the class today. So tomorrow, first and second class we have. Please, I will again put these videos in this LMS. Dr. YouTube also is there in our PhD department. So please go through that. If you are want to listen again once again.